Have you ever wondered how experts figure out where to place a new school, track the spread of a disease, or predict which areas are most vulnerable to natural disasters? It all comes down to understanding locations and relationships. Geographic spatial analysis is a powerful suite of techniques used to examine the characteristics of and relationships between features in geographic space. At its core, it seeks to uncover patterns, trends, and anomalies that might not be obvious from simply looking at a map. Key methods include spatial queries, measurements, transformations, and various statistical and interpolation techniques. The why behind these methods is rooted in the very nature of geographic data, which inherently possesses both attribute information, describing what something is, and spatial information, indicating where it is. Different analytical methods allow us to ask and answer specific questions about this dual nature. For instance, distance measurements help us understand proximity, while overlay operations combine different layers of information, like population density with flood zones, to reveal areas of high risk. Network analysis helps optimize routes and understand connectivity, which is vital for logistics and emergency services. These techniques are selected based on the research question, the type of data available, and the desired outcome, allowing us to move beyond simple visualization to deep insight. To put these methods into practice, imagine you are a city planner. You might use a spatial query to find all vacant lots within 1 mile of a public transportation stop. You could then employ a buffering technique to delineate areas around hospitals to identify service gaps. Furthermore, using interpolation, you might estimate air pollution levels across an entire urban area based on measurements from scattered monitoring stations. Each method provides a piece of the puzzle, helping you make informed decisions about resource allocation and urban development. A fascinating insider detail is the concept of Tobler's first law of geography, which states that everything is related to everything else, but near things are more related than distant things. This fundamental principle underpins many spatial statistical methods, guiding how we analyze clustering, dispersion, and spatial autocorrelation. Understanding this law helps explain why methods like kernel density estimation, which identifies hot spots, are so effective in geographic analysis. Ultimately, mastering the diverse methods of geographic spatial analysis equips you with the tools to dissect complex real-world problems, transforming raw geographic data into actionable intelligence. By applying these techniques, you can not only understand what is happening, but also where, why, and what if, leading to more informed decisions and a deeper appreciation for the intricate connections within our world.